Today we are going to talk about the lens formula, magnification, sign conventions as well, and for lenses, and we'll try to solve few numericals as well, right? So lens formula, we've already done mirror formula, and you already know the formula for mirror formula is 1 by f is 1 by v plus 1 by u, where f is focal length, v is the image distance, and u is the object distance from the mirror. Now we are going to talk about lens formula. And lens formula is 1 by f is equal to 1 by v minus 1 by u, right? So instead of plus, we have minus here, where you know f is the focal length of the lens, v is for image distance, and u is for object distance, fine? So this is the only difference. There is a difference of minus sign. In mirror formula we have plus here, in lens formula we have minus here. Now, the formula for magnification of image formed by lenses, which is equal to the ratio of height of image to the height of object. This is also related to V by U by this formula, which is M is equal to HI by HO is equal to V by U. Right? I am writing HI, HO so that we remember that it's the ratio of height of image to height of object. It can be written as h dash by h as well. Fine. Just for remembering, we are using these subscripts as I and O. Fine. So these are the two formulas. We will be solving questions based on them. But before that, let's revise the sign conventions. The sign conventions for the lenses are similar to that for the mirrors, which we've already done. So let's quickly revise. The sign conventions are as follows. Let's say this is a convex lens. First of the sign convention is we consider conventionally that the light is falling on the lens from left to right. Fine. This is the direction of the incident light that we consider. You've seen we have drawn so many ray diagrams, and we've always taken the object to the left of the lens. We always draw object to the left of the lens. So conventionally we assume light is falling on the lens from left to right. That is the first sign convention. Secondly, all the distances measured in the lenses are measured from the optical center. All the distances which are horizontally measured are measured from the optical center. Fine. Thirdly, the distances measured in the direction of incident light are taken as positive. That means the distance which is measured from O and we measure it from left to right, that we take as positive. Distances measured from right to left, that is against the direction of incident light, are taken as negative. Fine. All the distances which are measured perpendicularly above the principal axis are taken as positive, and all the distances measured perpendicularly below the principal axis are taken as negative. These are the sign conventions which are similar to that of the mirrors. Fine. So based on these sign conventions, what sign we can assign to U, V, F, H, O, H, I, etc. Let's quickly discuss. Already we have discussed this for mirrors, but we'll quickly revise it for lenses as well. Fine. So I'll redraw this diagram for you. Now if you want to remember the sign conventions, simply you can draw a diagram like this, and you can remember this is optical center. This distance will be positive left to right, right to left will be negative, upward will be positive, and downward will be negative. We can remember this, and through this diagram we can now use this diagram to assign the sign. Now U is the object distance. Object is always kept to the left of the lens. So object distance will always be negative. Whatever may be the lens, whether it's a concave lens, whether it's a convex lens. In a concave lens also, the object is always kept to the left of the lens. So, object is always here. So, U is always negative. V, let's talk about V, which is the image distance for a real image. Now, V for a real image will be, now, you know that a real image in a convex lens is formed, a real image is formed, and whenever a real image is formed, it's always formed on the other side of the lens. If the object is here, the real inverted image is formed like this on the other side of the lens. Fine. Always to the right of the lens. That means for a real image, V will always be positive, because real image is being formed to the right of the lens. So if we start measuring the distance of the image from the optical center, We are measuring it from left to right, so V will be positive. V for a virtual image. Now virtual image, how is it formed? In a concave lens, if the object is here, the virtual image is formed like this on the same side as the object. Similarly, in a convex lens also, a virtual magnified image is also formed on the same side of the lens as the object. So virtual image is always formed on the left of the lens. That means V for virtual image will be always negative. The image distance of a virtual image will be taken as negative. Now this is important because in mirrors, V of a real image is negative, whereas in lenses it is positive. In mirrors, V for a virtual image is positive, whereas in lenses it is negative. So it is opposite for mirrors and lenses. This is important. These two signs change. For lenses and mirrors, they are different. Then height of object. We keep always the object above the principal axis. So height of object is always positive. Height of image for a real image, real image is always inverted, formed below the principal axis. So height of image will be negative for a real image. Height of image for a virtual image is always erect, formed above the principal axis. So height of image will be always positive. As you know, virtual image is always erect and formed above the principal axis. So height of image is positive. This is the same in the mirrors as well. What is the sign for focal length of a convex lens? Convex lens, the rays fall from left to right, and the focus is on the other side of the lens. Focus, it has a real focus. So focus is on the other side of the lens. That means focal length will be from left to right. You have to measure. So focal length of a convex lens will be positive. In a concave lens, the focus is to the left of the lens. If the rays are falling like this parallel to the principal axis, the rays diverge and they appear to meet at focus. So focus is like this. So focal length will be negative. Focus is virtual in a concave lens. So focal length of a concave lens will be negative. Fine. And if you remember, for a convex mirror, focal length is positive, and for a concave mirror also, focal length is negative. So this is similar to that. Now magnification. Magnification will be for a real image. What will be the sign for magnification of a real image? We know that what? Magnification is HI by HO. Height of image by height of object. And height of image for a real image, height of image is negative. For a real image, height of image is negative. Height of object is always positive. So M for a real image will be negative. And M for a virtual image, if we talk about, M for a virtual image will be positive. Because height of image by height of object, height of image is also positive for a virtual image, height of object is also positive for a virtual image. So M for a virtual image will be positive, M for a real image will be negative. So these are the signs, according to the sign conventions, these are the signs that we have to remember. Fine, if we remember how to assign the signs to all these values, we will always get our numericals right. Okay, so that's about sign conventions. Now let's talk a little bit more about M that I have already told you. Now M is for mirrors, we've already discussed this. M is HI by HO. So it is real for real image, negative for virtual image, positive. Sign of M also, let's quickly revise. M is equal to 1 means HI is equal to HO. M greater than 1 means HI bigger than HO. M less than 1 means HI less than HO. Obviously, from this relation, we derive this information. That means M is equal to 1 means height of image is same as that of object. M more than 1 means, if the value M is more than 1, it can be 1.52, 2.53, whatever the value may be. That means height of image is more than height of object. That means the image is magnified. Value of M less than 1 means height of image is less than height of object, that means image is diminished. So, and sign, obviously we've already discussed what the sign of M indicates. So if I give you a value now, let's say M is plus 0.75. What is the nature of the image? Nature of the image will be, plus means virtual, erect, and 0.75 is less than 1, that means image is diminished. What is the nature of the lens now? Virtual, erect, diminished image means which lens? Means obviously concave lens. A concave lens forms this image. If I say M is, let's say, minus 0.75, minus means real inverted image and 0.75 means diminished image. Now real inverted diminished image is formed in which lens? What will be the nature of the lens? If you are given this value, you can be asked to write the nature of the image, which is this. You can be asked to write the nature of the lens, which is this here. In this case, what is the nature of the lens? Real inverted diminished image is always formed in a convex lens. So the nature of image will be convex lens. So this is how we read the value of M. Fine. Now we will be solving few numericals based on, one or two numericals may be based on the lens formula and magnification. Okay. So this question, an object 60 cm from a lens gives a virtual image at a distance of 20 cm in front of the lens. What is the focal length of the lens and is the lens converging or diverging? Now, first of all, what is given, that is to be written. We have given that object is at 60 cm from the lens. That means we are given U and U will be minus 60 cm. You know that U is always negative. It forms a virtual image which is at a distance of 20 cm. So image distance is 20 cm. Now the image is virtual. Virtual means image which is formed on the left side of the lens. So V will also be negative. So V is negative. This is important. This sign, if you take it wrong, the question will go wrong. What is the focal length? We know lens formula is 1 by F is equal to 1 by V minus 1 by U. We put the values minus. Fine. So 1 by F is equal to minus 1 by 20 plus 1 by 60 and we solve it. Minus 3 plus 1. 1 by F is equal to minus 2 by 60. So our F comes out to be minus 30 centimeters. Now F is minus 30 centimeter. The question, next part of the question says, is the lens converging or diverging? F is minus means the lens is concave. And concave lens is a diverging lens. So the lens is diverging in nature. Now let's solve another numerical. And the next question now is, a lens of focal length 20 cm is used to produce a 5 times magnified image of a film slide on a screen. How far must the slide be from the lens? Now let's see what is given in the question. It is given the lens of focal length 20 cm. Now it's not given which lens it is. So let's read the further question and try to find out which lens it is. It is used to produce a 5 times magnified image of a film slide on a screen. That means the image formed is on a screen. That means the lens is forming a real image. Now if it is forming a real image, it has to be a convex lens. A concave lens can never form a real image. So it is a convex lens, that means, and so F is plus 20. Fine. Now it is given that it is forming a 5 times magnified image. M is 5. And on a screen, image is formed on a screen. That means image is 5 times magnified as well as real. Fine, because this on a screen, this statement says image is on a screen. So image is 5 times magnified, so M is 5 and it is real, that means M is minus 5. Okay? So identifying the signs is very, very important. So from here we were given F20 and M5, that was easy to recognize. But what sign should be assigned to F, that we have seen from the statement that image is formed on a screen. This on a screen statement helped us to find out that F should be positive because it's a convex lens and the image is real, so M should be minus 5. Okay, so if we know this, now we have to find out how far the slide must be placed from the lens. That means we have to find out U. So we know that m, the formula we know is m is equal to v by u. That means we know minus 5 is equal to v by u. From here we can say v is equal to minus 5u. And if we use this in the length formula, which is 1 by f is 1 by v minus 1 by u, we have 1 by 20. Instead of v, I'll write minus 5u minus 1 by u. 5u minus 1 minus 5 is 1 by 20, which is, we cross multiply 5u this side, minus 6 into 20 that side. So u will be minus 6 into 20 by 5. Fine, this is all simple mathematical steps. So this is 5 fours are 20, so 6 fours are 24, minus 24 centimeters is our u. So the slide must be placed 24 centimeter to the left of the lens. We can also find v from here, although it's not asked, but let me find out and tell you. So minus 5 into minus 24, so it is 120 centimeter, and v is coming out to be positive, which very well shows that it is a real image. V is positive for a real image in lenses. Right? So the question I've taken, because in this question we are not directly given the signs, we have to understand from the statement of the question what is the sign of f and what is the sign of m. Fine, that's why I've taken this question. Let's solve one more numerical, the last one. So the next question says, an erect image 2 cm high is formed 12 cm from a lens. The object being 0.5 cm high, find the focal length of the lens. Now let's see what all is given. First of all, we write that. An erect image 2 cm height. That means height of image is given to us 2 cm, and it is erect image, so plus 2 cm. Fine. Is formed 12 cm from a lens. Now image is formed at 12 cm from the lens. That means V is 12 cm, and it is an erect image. That means it is a virtual image being formed from the lens. Virtual image, V will be negative. We know for a virtual image in lenses, V is negative. It is formed on the left side of the lens. So V is minus 12 given to us. So V is minus 12. The object being 0.5 centimeter high. That means height of object is 0.5 centimeter. Height of object is always taken positive. Fine. So we have to find out the focal length of the lens. So this is all is given to us. So from here, because it is erect image, we have taken HI as positive and we have taken V as negative. So this erect image, this phrase is important in this question, which helps us to tell us the sign of HI as well as V. So now we have to find out F. We know F we can find out if we have V and U from the lens formula. We are not given U, so first we will find out U, and we know HI by HO is equal to V by U. This is the formula we know. So we have 2 by 0.5 is equal to V is minus 12, U we have to find out, and U is equal to there. Okay, first, so here on the left hand side we get, so 4 is equal to minus 12 by U, and we cross multiply, U is equal to minus 12 by 4, which is equal to minus 3 centimeters. So U is minus 3 centimeter. Now we'll use this U in the lens formula and we'll get 1 by F is equal to 1 by V minus 1 by U. V is given to us as minus 12. So minus 12 minus, this is minus 3. So we have minus 1 by 12 plus 1 by 3. And we find out 12 minus 1 plus 4 is 1 by F. So this is equal to 3 by 12, and F is coming out to be 12 by 3, which is 4 centimeter. So F is coming out to be 4 centimeter. That means which lens it is? It is a convex lens. It's a converging lens. So F is 4 centimeter. U is minus 3. That means this is a case of convex lens when the object is between O and F. And in this case, the image should be virtual, erect and magnified. And we are getting virtual image and a magnified image. Obviously, HI is greater than HO, so it's a virtual, erect and magnified image. So this is how we solve questions based on this lens formula and magnification. Hope you've understood. In the next class, we'll take up the power of lens, which is the last topic of the chapter. Thank you and have a nice day.